Hey sixth graders, I just wanted to go over your notes for today. They don't take too much time, but after you finish these notes, you'll actually need the back of this paper for the constant of proportionality practice. It's a bunch of problems where it's just asking you who is correct. So for each problem, it's going to say, here's the problem, and it'll say Jill thinks the constant is 4, Jack thinks the constant is 6. Who is correct? And so on this space for number 1, you'll decide who you think is correct, and you'll give me an explanation why, right? Like, I think that Jill is correct because when I do y divided by x for all of these, I get 3. And she said that the constant is 3, something like that, right? So you're just answering who is correct. And this is going to be linked in Google Classroom, the actual assignment slides for you to see. And then you just use the back of this paper to do the work. But let's go ahead and talk about the notes. So mostly our notes today are just trying to figure out, is it proportional, right? Now I can say off bat that I know that this is not proportional, and it's because the equation is not in y equals kx form. It has a little bit extra, which mostly just means it has a starting fee. So this is like you charge $3 an hour for babysitting, so that's the 3x. And just $1 just because. So, if you babysit for 2 hours, it's going to be 3 times 2, which is 6, plus that $1 that you charge just because. And it's that additional $1 that throws off the proportionality, because we can't just say it's going to be times 3 every time because of that plus 1. However, we can use that equation to fill in this table, okay? So, let's go ahead and see what happens. Now we know that 0, 0 needs to be inside of any table that is proportional, because if you're not babysitting for any hours, then you're not making any money. But the interesting thing about this is if we make x 0, well, 3 times 0 is 0, and 0 plus 1 is 1. So this means even if you don't work any hours, you're still going to make $1. And we know off bat that this cannot be a proportional relationship for that very reason. But we can keep filling in the table. So let's say you work 1 hour. Well, you charge $3 an hour. So $3 times 1 hour is going to be $3, plus that 1 is going to be 4. So if you work 1 hour, you'll make $4. What if you work 3 hours? So 3 hours times 3, $3 an hour times 3 hours is $9, plus that $1 you charge would be $10, okay? I'm actually going to skip this one for right now. So we got 2.5 hours times $3 an hour is 7.5, plus that $1 you charge would be 8.5. And then this one is actually a little tricky. So we know how much you made, but we're trying to figure out how many hours you work. So we kind of have to work backwards. So it's at 16. So we first have to take away the $1 that you charge no matter what. And that's going to be 15. So that's actually how much you made just from working. Because remember, that $1 that you charge no matter what, you didn't actually get that from working hours. So when we take away 1 from 16, we get to 15, which means you made $15 just from working. And if you charge $3 an hour and made $15, that means you worked for 5 hours. So we can make sure that it lines up, right? 5 hours times $3 an hour. 5 times 3 is 15, plus that $1 extra will be 16. Now, if you look at this, there's no consistent way that you're getting from x to y. And we know that it wasn't going to happen because this is not proportional. We know it's not proportional for a couple reasons. It does not have the point 0, 0. It has the point 0, 1. Okay, so that was one way that we knew it. And there is no constant of proportionality in our table. How do you get from 1 to 4? That's times 4. But 3 times 4 is not 10, and 5 times 4 is not 16. So we can see there's no consistency to this. Therefore, it is not proportional. We also knew it was not proportional because this equation is not in y equals kx form. It has a little bit extra, like that $1 you charge just to start, just for showing up to their house, whether you babysit or not, you're going to charge that $1, okay? All right, so let's keep looking. It says select all the equations that are proportional. We know if they are going to be proportional, they need to be written in y equals kx form. It's a multiplicative relationship, and it is that multiplicative constant that keeps it proportional no matter what. So let's see. I'm looking for y equals kx. This one looks good. This one looks like it has extra. This is actually saying, and it's kind of flipped, but what it's saying is you charge $35 an hour, so $35 times the number of hours, and no matter what, you're going to charge them $500. So when they're trying to figure out how much money they're going to pay you, they pay you $35 for every hour plus $500 just for you agreeing to do it, right? So this is definitely not proportional, because that means even if you didn't work any hours, 35 times 0 is 0, you'd still make that $500, right? This one actually is proportional. I know sometimes we want to say it's not because it's in fraction form, but it is written in y equals kx. It just means your constant, or your thing that's keeping it proportional, is 1/2. Another way you could write it, if you didn't want it in fraction form, is as a decimal, and your constant would be 0.5. However, this last one is not proportional because it has that exponent, or that to the second power, or squared, and that is not in the form y equals kx. So how do we know they are proportional? Because they are in that form y equals kx with nothing extra. Alright, so here we go. Proportional or not. To go to a film festival, tickets are $2 per person plus a $3 service fee. Now, when you hear $2 per person, you should already be thinking that this is a multiplicative relationship, because it's going to be $2 times however many people go. And that is consistent, right? So sometimes we want to go, is this going to be proportional? Because $2 times the number of people is something that I can consistently rely on to figure out the price with a multiplicative relationship. But there's something that's throwing it off here, and it's that $3 service fee, right? So it means even if, regardless of the number of people that go to this film festival, you're going to pay this $3 service fee. It's a starting fee, which technically would mean even if no one goes, then you end up paying that $3 service fee. I know this is a bad example for that. It's like if no one goes, you don't pay anything. But it's just saying that that $3 service fee is going to be there regardless of the number of tickets that you end up paying, even if that was 0, even though that kind of is confusing to understand, okay? So let's go ahead and fill in this table. So if 0 people go, you're still going to pay $3. You're still going to pay that $3 service fee. However, if one person goes, so it's $2 per person, so that's going to be $2 for that one person, plus the $3 service fee, so this would be $5. If 4 people go at $2 per person, that's $8, plus the $3 service fee is going to be $11. I'm going to skip this one because it requires us to work backwards a little bit. But for this one, if 10 people go at $2 per person, that's going to be $20, and that $3 service fee would make that $23. Now I'm going to take this one right here. Remember, we got to kind of work backwards. So we're trying to figure out how many people went, or how much we paid just in tickets per person. Well, if we want to know how much we paid in just tickets per person, we have to get rid of that $3 service fee. So if we get rid of the $3 service fee, we can see that we paid $14 for the people, right? Because before we added the $3 service fee, we had to be at 14. So you can say, well, how many people would have to go for you to spend $14? And that would be 7. And we can check it. So this is saying 7 people went at $2 per person. 7 times 2 is 14, plus that $3 service fee would be 17. Okay? So then it says write an equation to represent the information. Well, it is going to be 2 times the number of people, but what would be different is that you have to add the $3 service fee, which means this is definitely not a proportional relationship because it's not in the form y equals kx. Therefore, there is no constant, and there is no consistent way to get from x to y. You can see 1 times 5 is 5, but 4 times 5 is not 11. Or if you go do all of your y over x's, you're not going to get the same constant each time. Alright, last one, proportional or not. Use the images to complete the table. Does the equation represent a proportional relationship? So we have a couple stages or pictures. And we can see that in stage 1, there are 2 dots. In stage 2, looks like there are 4 dots. In stage 3, there are 1, 2, 3, 4, 5, 6, 7, 8 dots. And in stage 4, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 dots. Alright, so is this proportional? Well, first things first, let's go ahead and find all our constants of proportionalities, or let's see if there's some consistency to this. Now, the nice thing is I can go do y over x for all of these, like 2 over 1, 4 over 2, 8 over 3, and 16 over 4. We can definitely do that to see if they're consistent. But because this is nice multiplication, I can actually just see 2 times 2 is 4, 1 times 2 is 2. Well, wait a second. 4 times 4 is 16. And I want to make sure this one was 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes. I'm actually not even sure 3 times what is 8. I could figure it out by doing y over x, or 8 over 3. Let me see. 8 over 3. And you end up getting 2.666667, so it's kind of just like times 2.7. But basically you can see there's no consistency to this. There's no constant pattern. You can't just say the number of dots is going to be 3 times the stage number, or the number of dots is going to be 5 times the stage number. So this is not a proportional relationship, okay? Go ahead and remember that you are going to flip this paper on the back and then find the activity in Google Classroom. Make sure you're actually giving me detailed descriptions for why you think that person is correct, right? Don't just say Jake is correct because I think so, right? Jake is correct because the constant of proportionality is this, because this, right? Because when I do y over x, I get 3 every time, or I can see a constant pattern of multiplying by 3. Or when I count the change in y over the change in x over the graph, this is what I get. Make sure you are given an explanation. If you do get stuck at any point, remember you have a couple notes that we did. So you have the notes from today. You also have the notes we did from Wednesday and Tuesday. And Tuesday's notes have all of them, right? It has how to find it from a table, graph, and equation. So I do hope you guys have a good rest of your day. If you finish this, then you can work on that quizzes review to practice for your intro. And I'll see you guys on Monday.